Okay, this is the product and quotient rule. Let's first look at the formula for that. For the product rule, if we're trying to find derivative of something times something else, P and Q are not numbers. If they're numbers, you don't use product rule. It's a lot easier way than that. Then we can find a product rule, find product of those, derivative-wise, with this. P prime Q plus P Q prime. That's going to be our formula we're going to work with. So let's look at our first problem. We've got f of x is equal to x to the fourth minus 3 times 5x squared plus 2x minus 3. Now, this one wouldn't be too bad. We could actually multiply everything out and then use our power rule, where we get x to a power. But there's no need. This would be our p, and this would be our q. For our formula, we need p prime and q prime. Well, p prime, the derivative of this would give us 4x to the third. The minus 3 drops away. For q prime, the derivative of that would give us 10x plus 2. Remember, take your power, put it out in front. So 5 times 2 is 10. Lower it by 1. And derivative of 2x gives you 2. And then our formula says p prime q plus p q prime. So our derivative, p prime was 4x to the third times q, which was 5x squared plus 2x minus 3. Plus p, which was x to the fourth minus 3, times q prime, which is 10x plus 2. Well, we'll do a little bit of simplifying here. We'll go ahead and get rid of these parentheses. 4x to the third times 5x squared gives us 20x to the fifth. 4x to the third times 2x gives us 8x to the fourth. 4x to the third times negative 3 gives us negative 12x to the third. And over here, x to the fourth times 10x gives us 10x to the fifth. X to the fourth times 2 gives us 2x to the fourth. Negative 3 times 10x gives us negative 30x. And negative 3 times negative 2 gives us negative 6. Now, oftentimes, simplifying means factoring out what they have in common. But these don't have anything in common, so there's nothing to factor out. So about the only thing you can do is get rid of parentheses and combine together like terms. Now, combine together like terms, we have 20x to the fifth plus 10x to the fifth. That gives us 30x to the fifth. We have 8x to the fourth plus 2x to the fourth. Well, that gives us 10x to the fourth. And I guess we have a negative 12x to the third. That's the only one I can see anyway. And then negative 30x and negative 6. And that would be our answer. Let's take a look at another product rule. We got f of x is equal to the fifth root of x times x minus 3. And let me shut something off here. PS3 is going. It sounds like a jet engine in here. It's not very quiet. Now, we know we have trouble working with radicals, period. So I don't want to work with the fifth root of x. I'm going to rewrite it as x 1/5. This will be a lot easier to work with. Now, this particular problem wouldn't be too bad for me to go ahead and multiply it through. But I want to show the product rule, so let me do it with that method. Now, we have something times something else. So this will be our p, and this will be our q. Well, from our formula, we need p prime. So take derivative of this, take your power, put it out in front, and lower that by 1. Well, that gives us 1/5 x to the negative 4/5. We don't want any negative exponents, so I'm going to take that and put it downstairs with 5. So we got x to the positive 4/5. Q prime. Well, derivative of x minus 3 is 1. So now we're ready for our formula. Continue it up here. P prime q plus p q prime. Okay. So our derivative, f prime of x, p prime we said was 1 over 5x to the 4/5 times q, which was x minus 3, plus p, which is x to the 1/5, times q prime, which was 1. So this gives us x minus 3 over 5x to the 4/5 plus x to the 1/5. And I'm going to put that over 1 because I'm going to want to merge these into a single fraction. Well, we need to get a common denominator, and the common denominator, since this one's 1, would be the 5x to the 4/5. And that's what I'm going to rewrite each one of these fractions with. Now this one here, the first one was okay, it already had it. But this one I multiplied the bottom part by 5x to the 4/5, so I have to multiply the top part by it. So I'm going to have x to the 1/5 times 5x to the 4/5. Now when I do that, I get x minus 3, 5x to the 4/5 plus 5 stays there. X to the 1/5 times x to the 4/5. If you got x to a power times x to a power, you add the exponents. If you think of a simpler example, like you got x squared times x to the 5th, that gives you x to the 7th. No different here. In fact, these are fractions, still holds true. So 1/5 plus 4/5 gives us 5/5. Actually, let me show the steps. We got 1/5 plus 4/5, and then our denominator is still the same. So that gives us x minus 3 over 5x to the 4/5 plus 5x, and 1/5 plus 4/5 gives us 5/5 or 1, like that. Well, since they have the same denominator now, I can add together the top parts. So I got 5x plus 5x gives us 6x minus 3 over 5x to the 4/5. Typically, simplified form means get a single fraction. They might or might not factor a 3 out of the top. If they do, it'd give you a 3 times 2x minus 1 over 5x to the 4/5. Sometimes you'll factor out the GCF and to see if something would cancel with what's down below. But this is our answer. And let me save this. Then we'll look at the quotient rule. So BC product quotient rule, page 01. Time for my little tablet to blow up, so let me bring up a new one. There we go. And let's look at the quotient rule. If we're finding the derivative of something divided by something else, q is not a number, then it's p prime q minus p q prime over q squared. Now, some books will have that in a different order. I personally like that order the best because it matches my product rule that I had written. Because my product rule is p prime q plus p q prime. So I try to keep it consistent in there and make it easier for students. So let's look at our third example. We've got f of x is equal to x to the third minus 8x plus 1 over x squared minus 4. Okay, so we got a quotient, something divided by something else. Well, our top part will be our p, and the bottom part will be our q. From our formula, we need p prime and q prime. So, p prime, the derivative of x to the third minus 8x plus 1 gives me 3x squared minus 8. And q prime will go give us 2x. So let's write down our formula. We got p prime q minus p q prime over q squared. So for our derivative, p prime was 3x squared minus 8. Q was x squared minus 4 minus p, which was x to the third minus 8x plus 1 times q prime, which was 2x, all over q squared, which was x squared minus 4 squared. Typically, simplified form means you don't leave a negative in there. Everything has to be a product. Now, I was looking at the top. I don't see that they have anything in common GCF-wise. So I'm just going to use brute force to get rid of the parentheses, combine together like terms, see what happens. Well, 3x squared times x squared gives us 3x to the fourth. 3x squared times negative 4 gives us negative 12x squared. Negative 8 times x squared gives us negative 8x squared. Negative 8 times negative 4 is 32. Minus, and I'll take 2x times each one of these terms. 2x times x to the third gives us 2x to the fourth. 2x times negative 8x gives us negative 16x squared. And 2x times 1 gives us 2x. All over x squared minus 4 squared. Okay. Negative 12x squared, negative 8x squared gives us negative 20x squared. Combine together like terms at any step. And this negative is going to flip the sign of everything inside here. So it becomes a negative 2x to the fourth plus 16x squared minus 2x. All over x squared minus 4 squared. Now the bottom part's simplified as much as we need it, because what that means is x squared minus 4 times x squared minus 4. Now we can actually factor this as x plus 2x minus 2, which we may end up doing that depending upon what the top part looks like. Okay, combine together like terms. We got 3x to the fourth minus 2x to the fourth. That gives us 1x to the fourth, or x to the fourth. We got negative 20x squared plus 16x squared. That gives us negative 4x squared. And we got negative 2x, sorry. Negative 2x and then plus 32. Over x squared minus 4 squared. Well, this top part, the question is whether you can factor it or not. You definitely can't factor by grouping. If I group the first two terms together and last two terms together, it doesn't work out nice. The question is if anything else can come out of it. And we can use a calculator to determine that. Or I could use the fundamental theorem of algebra and spend about 10 minutes on it. Which wouldn't be a bad 10 minutes. It would be kind of fun. I press y equals. I'll clear those out. Do a zoom. Choose 6 for z standard. Okay. Now we should be back where you are. That's from a previous problem. And let's type in the top part. So we got x to the fourth minus 4x squared minus 2x plus 32. And I'll down arrow to y2 and put a 0 there. You have to have a 0 on y2. Okay, so I'm going to do a second trace. Choose intersect. And it doesn't look like it's crossing anywhere here, which would imply to me that it's kind of weird. It doesn't cross anywhere. That it wouldn't cancel with anything down here, because the only thing I could do here is factor this as x plus 2, x minus 2. And then only places I'm interested in is 2, negative 2. It's kind of weird. I didn't find anything, though. Let me choose zoom. Sometimes this gives me a good good view, sometimes not. There it is, zoom fit. This tries to give you a picture of where exactly is the graph. Okay, so it's up there. Now if I press my trace, 0.32. So it doesn't even go down that low. So it doesn't even cross the x-axis. And you could use your arrow keys to trace that to see where in the world it's at. I think that's going up. Yeah, it is. Okay. What I'm going to do is zoom and choose 6 to set it back. Okay, so I can't factor the top part any, so that would be your answer. Okay, let me, I'm not sure if I have room for the next problem on here, so let me save that. Let's start a new page. Okay, and let's look at our next problem. Now, I'm going to do this one. First, I'm going to do it the hard way. And then I'm going to go back and show the easy way, just to point out how it'll save you so much work if you keep your eyes open. Okay, so I got x squared plus 7x plus 10. And we're looking at the hard way. Okay, I'm going to use my quotient rule. This would be P, and this would be Q. P prime would be 1. Q prime would be 2x plus 7. Now our formula, I always write down the formula each time. It helps me to remember it. Looks like this. So for our derivative, P prime we said was 1. Q is x squared plus 7x plus 10. This one may not come out that difficult the hard way. Some of them are really difficult. P is x plus 5. And Q prime is 2x plus 7. Over Q squared, which would be the x squared plus 7x plus 10 squared. Okay, now this top part looks like this factors. X plus 2 times x plus 5. Now when I factor that, you notice the top part, they both have an x plus 5 in common. Well, we'll come back to that. This down here, this looks like this factors. This would be x plus 2 times x plus 5 squared. Now on top part, since they have a x plus 5 in common, this is one group and this is another group. That's because this times this, that's considered one group. The minus is what separates the groups. We'll factor out an x plus 5, and that'll leave us x plus 2 minus, and then 2x plus 7 inside of parentheses. Now this down here, if that's squared, means I'm going to have x plus 2, x plus 5, and x plus 2, x plus 5. Well, one thing I noticed right away is here's an x plus 5 and here's an x plus 5. So those are going to cancel. Now here on top, I'm left with x plus 2. That negative out in front is going to flip the sign of everything inside, so it becomes a negative 2x minus 7 over x plus 2, x plus 2, x plus 5. Okay, combine together like terms. X minus 2x is negative x. 2 minus 7 is negative 5. And we got x plus 2, x plus 2, x plus 5. Now I can factor out a GCF on the top. They both have a negative 1 in common. And that leaves me a x plus 5 over all this. Okay, now this has an x plus 5, this has x plus 5. Notice everything's a product on top and the bottom. The reason we do that is see what we can cancel away. So as x plus 5's cancel. And we got negative 1 over x plus 2 squared. And that'd be our derivative. Well, let's look at an easier way. It's not exactly easy, so we'll just say easier way. Right to begin with, if you happen to see that you can factor the top and the bottom, go ahead and do so and see if something would cancel. The bottom part factors using the PSD method as x plus 2 times x plus 5. Now once I do that, I notice that the x plus 5's will cancel right away. And f of x is going to equal to 1 over x plus 2. Well, now we'll use our quotient rule. This will be p, and this will be q. P prime would be 0, q prime would be 1. So I got p prime q minus p q prime over q squared. So our derivative, p prime was 0, q was x plus 2, minus p, which was 1, times q prime, which was 1, over q squared, which was x plus 2 squared. Now 0 times anything drops away. Negative 1 times 1 is negative 1. And we get our same answer. And you see the problem is a lot simpler. A lot less work to do to get the same answer. So again, look for it. If you can factor the top, factor the bottom, do so, and see what can cancel. Now we're going to look at some other simplifying techniques, and I'm not going to do it the hard way anymore. If I see the shortcut, then I'll show you a shortcut. Let's take a look at this one. And I just don't know if I have room, though, so I hate to, especially if you print these out, I hate to like have a bunch of white space at the bottom, but oh well. Just paper. We've got to keep forestry industry in business. Okay, so number 5. Got f of x is equal to 2x minus 3 over the square root of x. Now this looks like the quotient rule, but we have a single item down below. If you have a single item, single term, single radical, or whatever, there's a technique you can do. I'm going to first rewrite it as x to the 1/2 power. If you have multiple terms up on top, you can take each one and put it over that denominator. Like this. Well, if we have x to a power over x to a power, you subtract the exponents. And if I were to put an exponent here, this is 1. And eye's burning. Let me scratch it for a minute. There we go. Okay. So this would become 1 minus 1/2 gives us 1/2. And here I want to take that x to the negative, or x to the 1/2 upstairs. It becomes x to the negative 1/2. So we get 3x to the negative 1/2. And now we can find our derivative. Take our power, put it out in front, lower it by 1. 1/2 minus 1 gives us negative 1/2. Take our power, put it out in front, and lower it by 1. Negative 1/2 minus 1 is going to give us negative 3/2, but I'll show the step. Okay, this 2 is going to cancel, so we got x to the negative 1/2. A negative times a negative is positive, and that gives us 3/2 x to the negative 3/2. Well, we don't want negative exponents, so we'll take them back downstairs, back to the denominator. So this is 1 over x to the 1/2 plus 3 over 2x to the 3/2. Okay, now we'd like to get a single fraction. Simplified form usually means single fraction. And it's always the x to the largest power, which is x to the 3/2. So I want, and also the 2, sorry. So that's going to be our common denominator. 2x to the 3/2. Now this one already has it, so we'll leave it alone. Now here, to get x to the 3/2, we have to multiply it times x to the 2 over 2. Because recall, if we have x to the 1/2 times x to the 2 over 2, you add the exponents, and that would give us x to the 3/2. So, since we multiplied the bottom part by x to the 2 over 2, we have to multiply the top part by it, and we also have to multiply it by the 2. So that'd be that. Which should give us 2x up on top over 2x to the 3/2 plus 3 over 2x to the 3/2. Well, they both have the same denominator now. So I'm going to add together the top parts. So I got 2x plus 3. And that would be our answer. Let me save that. Not sure why it does that. Let's look at the next problem. Now that one might have been questionable. If I had actually done it using the quotient rule, it might have been a little bit easier because it would already be in a single fraction. Just for fun. And I know my concept of fun is different than yours, but let's use the quotient rule. See how it comes out. Sometimes I can't look at these and see which one's the easier way. Now, definitely I need that as x to the 1/2. That goes without saying. Okay, this would be p, and this would be q. And I need p prime, which would be 2. And I need q prime, which would be 1/2 x to the negative 1/2. Take your power, put it out in front, lower that by 1. 1/2 minus 1 gives you a negative 1/2, which would give us 1 over 2x to the 1/2. And if it would help, go ahead and put that back into your square root form. I'm trying to think if it would help me in this one. Probably wouldn't. I'll go ahead and use that. So p prime q minus p q prime over q squared. P prime would be 2, q would be x to the 1/2, minus p, which is 2x minus 3, times q prime, which would be 1 over 2x to the 1/2, all over q squared, which would be x to the 1/2 squared. Well, that gives us 2x to the 1/2 minus 2x minus 3 over 2x to the 1/2. And when you raise an exponent to another exponent, you multiply the exponents. 1/2 times 2 gives us 1, or just x. Now, we can't have a fraction inside of a fraction, so we'll multiply everything by the LCM of all our inner denominators. The only inner denominator we have is the 2x to the 1/2, so we'll multiply everything by 2x to the 1/2. And multiply that times 2x to the 1/2. Well, 2 times 2 is 4. X to the 1/2 times x to the 1/2, you add the exponents. So that'd give me 1/2 plus 1/2. Over here, the 2x to the 1/2 is going to cancel. And we got a minus, and we're going to have to keep parentheses around 2x minus 3, because that needs a flip sign of both of those. Down below here, this is like x to the first power, and you're going to add the exponents. So that's 1 plus 1/2. So up on top here, 1/2 plus 1/2 is 1, so that's 4x. And this negative is going to flip the sign of everything, so it becomes a negative 2x plus 3. And then down here, 1 plus 1/2 gives us 3/2. So that gives us 2x plus 3 over 2x to the 3/2. Hopefully we came up with the same thing as we did last time. Let me see here, I'm just curious. Because I sometimes do not add numbers and multiply them and divide them and so forth correctly. 2x plus 3, 2x to the 3 halves. Yep, that's right. Okay. I don't know. This is probably about the same amount of effort on that case. So sometimes it'll make it easier, sometimes not. Sometimes it's the same amount. Let me save that. Definitely that first one I showed you, it saves you time to do that. Time for my tablet to blow up. Okay, let's look at our next problem. By the way, when you have radicals, they just come out nasty, period. We hate radicals when it comes to derivatives. Well, I don't, because I love math, but the average person hates it. Okay, now notice we have a single item downstairs, and this particular problem is a single term. So I'm going to split this up. I'll put the 5x squared over the 3x minus 7x over the 3x. Now I could have jumped right into the quotient rule, but after I do this, see, that gives us 5/3 x minus 7/3. Those x's cancel, and one of these x's goes away. Now to find our derivative of this would give us 5/3. And that's our answer. Now that one, definitely splitting it up saves you a lot of work. This next one is also one that will save us a ton of work. Got f of x is equal to x squared minus 25 over x plus 5. Excuse me. Well, I notice the top part is the difference of two squares, and it factors as x plus 5 times x minus 5. Okay. Now once I do that, I notice that they both have an x plus 5, so that's going to cancel. And our f of x is equal to x minus 5. So now to find our derivative of x is 1, and negative 5 drops away. So that's our answer. Let me save that. That would be tons of work, by the way, if you did the quotient rule. Fun work, but lots of work. Okay, why do you keep minimizing? Okay, let's look at our next problem. Well, this one's obviously not going to be nice. So we got f of x is equal to x minus 1 over x plus 5 times x squared plus 3x plus 5. Well, this is a product rule to begin with. So we have something times something else. So we need to find p prime and q prime. So over here, for p is equal to x minus 1 over x plus 5. Now, to find this, we have to use a quotient rule. And I'll use different variables. What will I use? U and v. So I'll say that's u, and that's v. So u prime would equal 1. V prime would equal 1. So our quotient rule is u prime v minus u v prime over v squared. So for p prime, u prime was 1. V is x plus 5 minus u, which was x minus 1, times v prime, which was 1, over v squared, which would be x plus 5 squared. Now since let me double check this. U prime v minus u v prime over v squared. Okay, u prime 1, x plus 5. Yep, that's right. Okay, so up on top here we got x plus 5. That negative flips the sign of everything that follows it, so we got negative x plus 1 over x plus 5 squared. So p prime is going to equal to, the x's cancel, we got 5 plus 1, which gives us 6, over x plus 5 squared. Okay, q prime. Q prime's easier. Q is equal to x squared plus 3x plus 5. Q prime would be 2x plus 3. Okay, back to our problem. Our product rule says p prime q plus p q prime. So for our derivative, p prime was this right here. So we got 6 over x plus 5 squared times q, which is all this. So x squared plus 3x plus 5 plus p, which is this. So x minus 1 over x plus 5 times q prime, which is 2x plus 3. Okay. Now, I don't know if it'll help us a whole lot. I was thinking about factoring out a 1 over x plus 5 because they have that in common. Yeah, maybe I'll do it. So when I factor that out, that gives me 6 over x plus 5 times x squared plus 3x plus 5 plus x minus 1 over 2x plus 3. And here I'll multiply the 6 through. So I got 6x squared plus 18x plus 30 over x plus 5. And I'm going to eventually merge these into a single fraction, so I'm going to put this over 1. And also multiply these through. So x times 2x is 2x squared. X times 3 is 3x. Negative 1 times 2x is negative 2x. And negative 1 times 3 is negative 3 over 1. Which gives us 1 over x plus 5. 6x squared plus 18x plus 30 over x plus 5. And top part here becomes 2x squared plus x minus 3 over 1. We got 1 over x plus 5. We don't get a common denominator of x plus 5. So we got 6x squared plus 18x plus 30. And we multiplied the bottom part by x plus 5, so we have to multiply the top part by x plus 5. Now I made these problems up, so they're probably coming out nastier than the average problem. Let's see, x plus 5. Got 6x squared plus 18x plus 30 over x plus 5. Multiply this through. X times 2x squared gives us 2x to the third. X times x squared, or x times x is x squared. X times negative 3 is negative 3x. 5 times 2x squared gives us 10x squared. 5 times x is 5x. And 5 times negative 3 is negative 15. Okay, now they both have a common denominator of x plus 5. So I'm going to merge them together into a single fraction. And I'm going to do some combining together to like terms. Here we have 2x to the third. Here we have a 6x squared, an x squared, and a 10x squared. 6 plus 1 is 7, plus 10 is 17. So we got 17x squared. Here we got an 18x minus 3x plus 5x. Okay, so 18 minus 3 is 15, plus 5 is 20, so we got 20x. And then we got 30 minus 15, which gives us 15. Now, it doesn't look like I can use factoring by grouping. It's a pretty good bet that won't actually work out nice. You have to do some planning for them to come out nice. So I got 2x to the third plus 17x squared plus 20x plus 15 over x plus 5 times x plus 5 is x plus 5 squared. Typically, simplified form means get a single fraction. It's hard to say where they might actually stop in this section. They might stop somewhere up here. Or they might take it down and simplify it further. So let me save that. Wish books were consistent and simplified form meant single fraction no matter what, no matter how much work it gave you. But some of them don't follow that. Okay, let's look at the next problem. Now, that, in case you're panicking, that was one of the hardest ones in that section. I chose one similar to it. Let's see, g of x is equal to x squared minus 5x plus 2. And then x to the third minus 4. And at 1/6. I might have actually, on that previous problem, I didn't want to do it because I wanted to show it. I might have actually multiplied the two polynomials together and just did the quotient rule and ignored the product rule altogether. Now this is asking us to find the equation of the tangent line. Okay, well, we have to find a derivative for the equation of the tangent line. Because remember, our first step is to find our derivative. Well, this is the product rule. This will be P, and this will be Q. So P prime would equal 2x minus 5. Q prime would equal 3x squared. And we got P prime Q plus P Q prime. So our derivative, P prime was 2x minus 5 times Q, which was x to the third minus 4, plus P, which was x squared minus 5x plus 2 times Q prime, which was 3x squared. Now, if we wanted to, we could spend a lot of time, maybe not a lot of time, but we could simplify this. Get rid of parentheses, combine together like terms, blah, blah, blah. But for this particular problem here, I know what I'm needing is I need slope. So our second step is to replace our notation, our derivative notation with m, and plug in the x part of our point, this is our x, into this right here. So this is going to be 2 times 1 minus 5, then 1 to the third minus 4, plus 1 squared minus 5 times 1 plus 2, and then 3 times 1 squared. Well, 2 times 1 is 2, minus 5 is negative 3. 1 to the third is 1, minus 4 is negative 3. That's weird. Let's see. Yeah, negative 3, negative 3. Over here, 1 squared is 1, minus 5, plus 2. And 1 squared is 1 times 3 is 3. So this gives us, oops, try it again. Negative 3 times negative 3 is 9. 1 minus 5 is negative 4, plus 2 is negative 2, times that is negative 6, which will give us 3. Yeah. That's m. Well, our third step, we're trying to find the equation of the tangent line. Like I say, we don't need to simplify that unless you just want to do it for fun, because we just want to find m anyway. Find the equation of the tangent line. We're going to plug this in for x. We'll plug that in for y. So y is 6. M was 3 from step 2, and x was 1, plus b. And then solve for b. 3 times 1 is 3. Take the 3 over, and we get b is equal to 3. Step 4 is to actually write our answer down. Well, we found m, which was 3, and we found b, which is 3. So that'd be our answer. Assuming I didn't make a math error somewhere. Yeah, I might have room for the next one. This is wanting us to find the equation of the tangent line again. So we got f of x is equal to 3x minus 2 over x minus 2 at 0.45. Okay, so first step is to find our derivative. Top part is p, bottom part is q. So p prime will equal 3, q prime will be 1. And for our derivative, we're going to have p prime q minus p q prime over q squared. Now for our derivative, p prime was 3 times q, which is x minus 2, minus p, which was 3x minus 2, times q prime, which was 1, over q squared, which would be x minus 2 squared. I'll simplify this a little bit. 3 times x is 3x, 3 times negative 2 is negative 6. That negative is going to flip the sign of both of those, so that becomes negative 3x plus 2 over x minus 2 squared. 3x minus 3x drops away, negative 6 plus 2 is negative 4, so we got negative 4 over x minus 2 squared. Now our second step, change our notation to m and plug in the x part of our point. Well, let's go back up to the top. The x part of our point is the 4. So we plug 4 in for the x. So we got negative 4 over 4 minus 2 squared. 4 minus 2 is 2. 2 squared is 4, so that gives us a negative 1. So this is continuing from the bottom. We just said m is equal to negative 1. Now, to find the equation of the tangent line, we're going to plug this in for x, plug this in for y. So we got 5 for the y. M we said was negative 1, and x is 4, plus b, and solve for b. Well, negative 1 times 4 is negative 4. Take negative 4 over the left side, becomes a positive 4, and you get b is equal to 9. Well, step 4, we can't forget our answer. We just found m, which is negative 1. So we got negative 1x, and b, which is 9. So our answer is y is equal to negative x plus 9. And let me save that. And let's do our last problem. Grab a drink. It says, find a point, if any, at which the graph of f has a horizontal tangent. Well, first thing we need to do is find our derivative. So this is p, and this is q. P prime will be 4, q prime will be 2x. So our first step is to find our derivative. And let me write down the formula. So f prime of x, p prime was 4, q is x squared plus 3, minus p, which is 4x plus 4, times q prime, which was q prime, which was 2x, over q squared. So we got x squared plus 3 squared. Okay, so we got 4 times x squared plus 3. Now I can factor a 4 out of this, and that leaves us x plus 1 over this. Now I can factor a 4 out because they have that in common, and that gives leaves us x squared plus 3 here, minus x plus 1 times 2x, and x squared plus 3 squared Again, if you can factor out GCF. So then I got x squared plus 3 minus, and I'm going to multiply the 2x through. 2x times x is 2x squared. 2x times 1 is 2x over this. So that gives us x squared plus 3. Now negative flips the sign of both of those. So it becomes negative 2x squared minus 2x over this. Which x squared minus 2x squared gives us negative x squared minus 2x plus 3. Now I can factor a negative 1 up, as my first term is negative. So this becomes a negative 4. Then x squared plus 2x minus 3. And that's our derivative. Now, second step is to set that equal to 0 and solve it. Well, if I got negative 4, and I'll change that to parentheses, x squared plus 2x minus 3 over x squared plus 3 squared equal to 0. This is a rational equation, and we'll multiply both sides by the x squared plus 3 squared to get rid of that rational equation, or to get rid of the rational part, sorry. X squared plus 2x minus 3. Same thing here. When we do that, this x squared plus 3, all of it squared, is going to cancel with that one. And we're left with negative 4 times x squared plus 2x minus 3. And 0 times anything is 0. Well, the trick here, and this is probably the only time I'll actually show that, is that whenever you have a fraction equal to 0, and you're actually trying to solve where, find the zeros, find out where it's equal to 0. There's another case of critical numbers where we would want to set the denominator equal to 0. But for the most part, if you're solving, then you just set the top part equal to 0, because it always works out that way. Now this factors as x plus 3 times x minus 1. Then we never set a number equal to 0, so we'll set the x plus 3 equal to 0, and we'll set the x minus 1 equal to 0. And we get x is equal to negative 3, and x is equal to positive 1. Negative 3, positive 1. That's probably enough room. Negative 3, positive 1. Well, now we need to find, the question was, let me actually get where I need to go right there. Question was, find the points. So now we need to take these values and plug them into our original function and get our y part. So f of x, which is the same as y, is equal to 4x plus 4 over x squared plus 3. So 4x plus 4 over x squared plus 3. So we'll plug in negative 3 here. So we got 4 times negative 3 plus 4 over negative 3 squared plus 3. And here we got 4 times 1 plus 4 over 1 squared plus 3. Well, 4 times negative 3 is negative 12. So we got negative 12 plus 4. Negative 3 squared is 9 plus 3, so that gives us negative 8 over 12, which is top and bottom both divisible by 4. That gives us negative 2 over 3. And don't circle that. That's not our answer. Okay, part of our answer. And do the same thing here. 4 times 1 is 4 plus 4. That gives us 1 plus 3. That gives us 8 over 4, or gives us 2. Okay, so this one we plugged in negative 3. So this point would be negative 3, negative 2/3. This one would be 1, 2. And those would be our points where there's a horizontal tangent line. So let me save that. And we'll be done with that section. Which is good, because I've been drinking too much pop, and nature's calling really bad. So we stop the recorder here. And I'll stop the other recorder too.